Hey folks, so this is Shetz, and this is the notes on lesson 17, equations of lines and the coordinate plane. So we know that slope, the m, is equal to rise over the run. And rising means to go up and down, and that's your y-axis, delta y over delta x. Delta just means the change in the y's. So our differences in our y's, whoops, that should be a y1. And then our running is across the green grass, that's our x-axis. So there you go, there's your slope formula, y2 minus y1 over x2 minus x1. Positive slope, you'll see lines that go like that, that's going uphill. Negative slope, that's lines that go downhill like that. Zero slope, would be looking like that, and that's a horizontal line. When I spell horizontal, notice my O is extra big for zero slope. So this is a horizontal line, and that has a slope. It is zero. Undefined slope would be a vertical line like that. Okay, so let me just scroll down here. And we need to find the slope of each line. Well, pick 2 points where it crosses nicely. Looks like, let's just go with this point and this point. All right, it's crossing very nicely. So we go down 1, that would be negative. Always go up or down first. So I went down 1 and 1 to the right, which is positive. Whoops. Which is a positive. So there's a -1 slope. Great. On this line here, well, this looks like a nice crossing right there. That certainly does not, neither does that, but that looks like it's crossing nicely. Okay, so go from this dot, I go down 1, that's -1, and I run 1, 2, 3. So there's my slope, a -1/3. And again, please do a nanosecond check. This line going downhill, my slope better be negative. This line also goes downhill, not as steep. And look, we don't have as big of a number. There's a negative going downhill. This slope here on this guy, I know it's going uphill, so I automatically know it's going to be a positive slope. So let's see where this crosses nicely. Well, it looks like this right here crosses very nicely right there, and also right there it's crossing nicely. All right, well, I'm going to start here. Let's count. 1, 2, 3, 4, 5. That's this rise of 5, and then we ran 1, 2. 5 over 2 is your slope. Great. Let's scroll down a little bit more. Okay. So -2, 1. -2, 1 is right here. And now 3, 5. Over 3, 1, 2, 3, 4, 5. And we're going to calculate it mathematically. It doesn't matter which y value you start with. You may start with a 1 or you may start with a 5. I'm going to start with a 1 minus the other y value is 5. Come back to where you started. You must pick this -2 because you started with the 1 right here is the 1. Then you always come back to where you started, -2 minus, what are we minusing? A 3. So this gives us a -4 over -5. Negative over negative is positive 4/5. And notice when I draw my line, it is in a positive slope. This is going up. This slope is going up. It's uphill. My answer better be positive. Let's just check to make sure. We go, start here, 1, 2, 3, 4. 1, 2, 3, 4, 5. 4 over 5 is my slope. And finally, we'll get to our last problem. Draw a line through the point 1, 2, 1, 2, right here. And now from that dot, we have to go up 5 and over 4. 1, 2, 3, 4, 5, and over 4. Well, golly gee, that's 5 over 4, but guess what? I ran out of room, so doesn't negative 5 over negative 4 also equal 5 over 4? So we're going to go down 4, and instead of to the right, we go to the left 4. Down 1, 2, 3, 4, 5, and to the left 4, 1, 2, 3, 4. There you go. We went through the point 1, 2. And there you go. If I ran out of room, 1, 2, 3, 4, 5, up, over 4, 1, 2, 3, 4. As you can see, this line would continue to hit it. So, as you recall, uphill lines have positive slope. That's like this guy. And this guy here, that's a downhill line, have negative slope. You all remember y equals mx plus b, that is slope-intercept form from Algebra 1. My m, the coefficient in front of my x, is my slope, and b is where this line will cross the y-axis. Therefore, it's a y-intercept. There you go, folks. Little review from last year, Algebra 1. Hope you like it.